Here we go. We are finding the volume of the solid found by revolving the curve y equals 2 plus x cosine x over the interval from -2 to 2 about the x-axis. All right, so they gave us the pictures here to try to start us off on the right path. You have this graph right here. They've already made this line for you, but that line is a line of 2 plus x cosine x. It gives you that shape right there. You are taking that line, and you are also going on the interval from -2 to 2. So you're going this line right here, that's x equals -2. And that value right there, that's x equals +2. And it's going to make this shape right here. You've got this area. You are going to take that shape and you're going to revolve it around the x-axis. This is your x-axis. This guy right here. Show me with your finger, what does revolving around the x-axis look like? Whee, this way. Okay, you're revolving around the x-axis. So if you were to take this shape, you would fold it down this direction and you'd make a cool little goldfish. Yeah, it is a snack that smiles back. You've got that shape, okay? You're revolving. When you revolve something, what is if you were to slice it, if you were to make a cross section, what's your shape going to be? A circle. Your circles are going to go like this. You would have a circle like that, and you'd have a smaller circle like that, and then you'd have a bigger circle like that, and a bigger one there, and then a smaller one again, and your circles would go that direction. Okay, down below there's a 3D rendering of it that might be a little bit clearer. We're finding volume. What do you need to do in order to find volume? You are integrating the area. That's just like what we did the whole last part, the whole last chapter. We integrate the area where right there I'm going to put the area, and when I say the area, it's the area of our cross sections. From when to when am I stacking my circles? -2 to 2. This is called disk method. Okay? Disk is a fancy word for circles. We're taking a bunch of disks. If you were to slice this thing up into little baby parts, you'd have a whole lot of disks. And when you put them together, it's going to make a shape. That's what's happening here. Okay, -2 and 2, are those x values or y values? X, so this is a dx problem. And so the equation that I'm going to write here for area is going to have x's in it. The area of my cross section is an area of a circle. The area of a circle is pi r squared. And so my formula that I'm going to fill in down here is pi r squared. That's what I'm going to integrate. All I need to do is figure out what my radius is. If I know what my radius is, then I've got an answer. When do I make the radius of my circle from? From what line to what line are you going to make your radius? From here to here, from here to here, from here to here. Would you agree that these are the semicircles? Or the, not semicircles, the radiuses of my circles? Those went from 2 plus x cosine x. That's the top line, because we always go top to bottom, or we could go right to left, but that's not for this graph. Top minus bottom, what's my bottom going to be? 0. That's my equation. Obviously, I don't need the -0 because it's -0. That's what my radius is going to be, and so right here inside the parentheses, I'm filling in that. 2 plus x cosine x, all squared, times pi. Integrate that thing. Use your calculator. Make sure you can do this. The number one mistake you're making today is, can I type that into my calculator correctly or not? Try it. Thumbs up if your number is bigger than 25. Thumbs down if your number is less than 25. Thumbs up for bigger than 70. Thumbs down for less than 70. You type that in, you hit enter. Your volume is 52.429. 52.429. Questions on the first one? It's not that crazy difficult once you get them figured out. Let's do it again. Number 2 says find the volume of the solid used by revolving the curve y equals x plus 1 on the interval from 0 to 3 about the x-axis. We have our line. We're revolving about the x-axis. We have the line y equals x plus 1, so I'm starting up there. It's got a slope of 1. It's a line. It's a y-intercept of 1. Should look something like this. And you're going in between the lines 0 and 3. You're on that interval. So this is the shaded region that they're referring to, this spot right here. Show me with your fingers, what does revolving about the x-axis look like? This way. We're going vertically. We're revolving down. And so that this shape, when I revolve it down, is going to look like this. All right, so it's going to be a big megaphone kind of thing. And so your circles are looking like this. They're going this way. This way. I think drawing in the circles is very helpful for you understanding. We're finding volume. What do you need to do to find volume? Integrate what? Integrate the area of my cross section. Okay? And so that's when I'm going to integrate. Fill that thing in. Do the rest of this problem without me. We are trying to figure out the bounds here. Riley, where did you put your bounds from? When did you stack these circles? 0 to 4. She's starting here. She made her circles all the way out here to 4. 0 and 4 are those x values or y values. So this is a dx problem. Our cross-section are of circles. So if the area of a circle is pi r squared. And so we are plugging into pi r squared. All we need to do is find our radius. Yes, sir? Yeah, it is 0 to 3. My fault. It is 0 to 3. My graph looks bad. It's 0 to 3. Yeah, we want x values here. 0 to 3, pi r squared. All we need is my equation. When did I make my radiuses from? And so, Lily, when did you draw a radius of this circle from? Yep, x plus 1 down to the x-axis. X plus 1 down to the x-axis. All of these lines right there are the radius. And so her radius goes from the top line, from x plus 1, minus the bottom line. Her bottom line is 0. And so obviously she doesn't need that. She's just going to integrate x plus 1 all squared. Thumbs up if you got a number bigger than 60. Thumbs down if you got a number less than 60. Thumbs up for bigger than 70. Less than 70. Kyle, what'd you get? Anybody got an issue with that? Anyone need to see it? Cool. Flip it over. I like question 3. It is written awful. Okay? And so I'm going to adjust question 3 because I don't like how it's written at all. So we're going to find the volume of the solid found by revolving the curve y equals x plus 1. Cross out all this. And y equals 4 about the y-axis. So we just cross out that interval. I don't like any of that. The line y equals x plus 1 and y equals 4. It's a badly written question. Okay, I've fixed it now. It's great. It's wonderful. It looks very similar to the last question. We changed the interval, but that's not really the main issue. But the difference now is we're revolving around the y-axis. So let's draw a picture of this. So same lines, x plus 1, 1, 2, 3 is really all I need. Here is my line going this direction. And then I'm taking that line and y equals 4, which is this line right here. If I drew better pictures, they would match up. But that's the line y equals 4. The area between those curves is this shape right here. Everybody see what's happening there? That's my area. I'm revolving it about the y-axis. Show me with your finger, what does revolving about the y-axis look like? This one, okay? Wave your shirt around your head like a helicopter kind of a direction. That's what we're doing here. So we're taking this thing and you're revolving it this way. And so you're getting this shape here as I revolve it around. And so my circles this time are going, like your finger was just moving, this direction. This direction. We're revolving that way. We're finding volume. To find volume, we integrate the area. From when to when did we stack our circles? This time it is from 1 to 4. We started our circles right here. We kept drawing them all the way up to the top to 4. 1 and 4, are those x values or are those y values? Those are y's, so this is a dy problem. Before I go too much further, I should think, oh no, it's a dy problem. If it's a dy problem, that means that my equations need to be x equals equations. So this line over here, yeah, it's y equals x plus 1, but because I'm going to have to use it right here, I'd like it to be an x equals equation because it's going to put it in terms of y. And so subtract 1. That's going to be the equation that I'm using for talking about that line over here. In order to talk about this line, I'm using y minus 1. Everybody with me? My cross sections of this thing. It's the area of a circle still. So it's still pi r squared. So it's pi r squared. All I need to do is find my radius. Where we spun around the y-axis. So if we're spinning around the y-axis, it's not top to bottom anymore. Now it's right to left. So Daniel, what line here am I using for the right line? Yep, this guy right here, that y minus 1. Right to left, what's my left line going to be for the radius? Yep, 0. That to that, that to that, that to that. So it is, the radius is the y minus 1, the right line, minus the left line. So the left line is 0 because it's the y-axis again. And so it's just y minus 1 all squared. Type that into your calculator. Make sure you can get a number. We type that in. We hit enter. We don't have a Y button. We use the X button instead. 28.274 is my correct answer. Oops. There we go. That's as hard as it's going to get for today. If you can understand that, you'll do pretty well. Everybody with me so far? We're going to do one more. So we're going to skip number 4. So if I don't do this, then you'll do it. We're going to skip number 4 because if you can do number 4, if you can do number 5, you can also do number 4. So we're going to jump down and do one last one here together. Let's look at example 5. Okay, example 5 says, find the volume of the solid generated by revolving the region in the first quadrant, bounded by this line, the x-axis and the y-axis, about the y-axis. So people earlier were giving me some grammatical issues here. You're revolving about the y-axis, and you're worried about the shape from this line, and that line. Go ahead and try to graph it, set it up. You're revolving around the y-axis, so make sure you have y in your equation. See if you can do that real quick. Talk with your neighbor and get it figured out. There's my graph. This is 4 minus x squared. That's that blue line. It's a half a parabola there because I only want to do that between the x-axis and the y-axis. It's that shaded region. Show me with your fingers, what are your bounds going to be from? From when to when are you going to bound this thing? 0 to 4 because I'm revolving around the y-axis. Is this a dx or a dy problem? Dy, because you're revolving it this way. And so your circles are going like this. You had these circles stacked from 0 to 4. It's going that direction. It's a dy problem, so it would be pretty beneficial to say, uh-oh, it's a dy problem. I should get this as an x equals equation. So if I get this as an x equals equation, I need to subtract 4. Move the negative over. And then square root. And so I'm going to rewrite that slightly. 4 minus y equals x. Technically, it's plus or minus, but I really only care about the right side. If you want to write the left side and make it negative. But I just care about this side right here. This blue line is this equation. It's a circle because I'm revolving, so it's always pi r squared. What's going to go inside the parentheses? The right line, which is this line right here. The square root of 4 minus y minus the left line. What's my left line going to be? The y-axis, it's 0. So from there to there, from there to there, from there to there, it's just that thing squared. You type that into your calculator, you hit enter, you should get 25.133. Show me how are you doing right now. 0's bad, 5's great. Hopefully you should feel like it's a little bit easier than yesterday. Tomorrow we'll build from it, but it's very similar to this. So if you're doing all right with this, tomorrow shouldn't be a whole lot harder.